So next we want to illustrate what's called a trapezoid rule. So instead of summing up areas of rectangles that approximate the area under the graph, we're going to sum up areas of trapezoids. So I'll show you the demonstration here. So here was the midpoint rule. Trapezoid rule with 4 trapezoids looks like that. So you've got this trapezoid, which is actually a triangle. Got a trapezoid here, one here, and one here. And so if you add those up, you actually, even with only 4 trapezoids, get a pretty good approximation, 1.38 versus 1.416. Again, as you add more trapezoids, you get a better and better approximation. You can see very little error right here. That little blue area is our error. So here, we're going to do n equals 2 again. So we're given n equal 2. So we want to use 2 trapezoids to approximate here. So our first trapezoid, well, our delta x is still 1 minus 0 over 2, which is 0.5. So our first trapezoid goes from 0 to 0.5. And so the right base of that is going to look like this. And then our left base right there. Along the bottom, we're right on the axis, and then along the top, right there. So we're going to add up that the area of that trapezoid, and then we'll have another trapezoid that goes from 0.5 to 1. And so that trapezoid is going to look something like this, and that looks like that's pretty close, really close to the graph. So we want to add up the areas of those 2 trapezoids. So recall here that the area of a trapezoid is the average base times the height. So it's the height times the average of the bases. Base 1 plus base 2 divide by 2. Okay, so if you do that for all the trapezoids that are involved, and then you simplify the problem algebraically, you get this expression that we have here. So the T stands for trapezoid rule. The N is the number of trapezoids. This is one formulation of the rule. You sum up from 1 to n the left end points, sum up from 1 to n the right end points, multiply by 1/2, so that's the average of all of the bases, and then times your height, which is the same for all of them, delta x. So another way to write that, if you expand both of those sums, is you get a delta x over 2 out in front, and then f at the left end point, x0, and then multipliers of 2 all the way through down to the f at the very right end point, which in our case is 1, our xn. So here what we can do is, this is going to be integral 0 to 1 e to the negative x squared dx. So if we're going to approximate this graphically, then we're just going to do the area of these 2 trapezoids and add them up. So we could use this formula if we wanted to. So this first trapezoid has a base of 0.5. I'm sorry, a height of 0.5, and then the 2 bases. It's going to average the 2 bases. So this height is 1. And then the length of this base, so if we go across here, that looks like, right there, maybe 0.8, 0.79, something like that. I'll do 0.8 to kind of simplify things. Divide by 2, so average in those bases. That's the first trapezoid. And then the height of this trapezoid is 1/2. That base there is the 0.8 again. Plus, and then this base here, just approximate things graphically. I'm going to say maybe 0.3. Because 3/5 would be more than halfway. And then divide by 2. So we can compute that. That's graphically. Or we could use, this formula, this simplified formula. I'm actually going back to the basic formulas of trapezoids. Now, if we want to do things numerically, then 0 is our x0, 0.5 is our x1, and 1 is our x2. So we are going to have f at the first point. Well, first we need our delta x over 2 out in front. So this would be a 0.5 divided by 2. And then we've got f at x0, that first value, which is 0. And then 2's for everything in the middle. So for us, there's only one value in the middle, 0.5. So 2 times f at 0.5. And then your last value has a multiplier 1. So that's f at x2, which is 1. And we could plug each of these into the function. So 0.5 divided by 2, that's 0.25. F at 0, e to the negative of 0 squared, plus 2 times e to the negative of 0.5 squared. That's f at 0.5. Plus, and then we're back down to 1 for our multiplier, so e to the negative of 1 squared, like so. Let's go ahead and compute this one first on the calculator, and then we'll go back and grab this one, see how close we were. So numerically, no, I guess it's not going to matter because I don't have this in the previous line. So let's go ahead and clear out. Let's go ahead and do this one up here. So I got a 0.5, parentheses, 1 plus 0.8, 1.8 divided by 2, so actually 0.9. And then plus, I'll have a 0.5 times 0.8, 1.1 divided by 2. Close that up. So 0.725. And this will be an approximation. And let's go ahead and do this one down here. So you got a 0.25 out in front. Second of ln is our e to the, well, negative of 0 squared, that's just 0. So we could put a 0 there. And then plus 2, second of ln is our e to the negative of 0.5 squared. So minus 0.5 squared. And then plus second function e, negative of 1 squared. 0.73137. So 7314 to 4 decimal places. And we're not too far off from our graphical estimate. So that's graphical and numerical estimates for trapezoid rule.